All right, so this is the absolute value. It moved left 6. So we're going to go left 6, put a point. And then you can use that negative 1/3 as the slope. We're going to go down 1/3 on each side. So it got like widened out. So what is our domain? What did you guys put for that? As you sweep left to right? Yeah, good. Everything, right? Nothing got left out. Range, you're going to have negative infinity up until what y value? Yeah, 0. Now that's where you do need a bracket because there is actually a point there at 0. All right, x-intercept, there's only one of them right here, -6, 0. Y-intercept is right here, 0, -2. Increasing and decreasing, you're going to read left to right. So hey guys, what is the graph doing first as I read left to right? Good, so increasing will be negative infinity to -6. And then decreasing will be -6 to infinity. What I get all the time is, Ms. Cole, why is this positive? Because we're reading left to right. And if you want to label that negative infinity, positive infinity, the left side and the right side to help you remember, and you can label this point too, -6, 0, whatever you need to do, label it to help you there. All right, maximum, it is this point, but we write it the other way around. So again, I usually write the ordered pair and then I just switch it. It's 0 at x equals -6. And we don't have a minimum because it's going to go down forever. And then your end behavior, if you wrote it like as x arrow negative infinity or whatever, I'm showing you the limit notation so you can get used to it. This is as we look to the left side, and then this is as we look to the right side. And what is the answer for both of them? Where are they both headed? Negative infinity. They're both going down. All right, so number 2, this graph is rational. What direction did it get shifted? Yeah, good, left 2, down 3. The entire axis is going to shift. We're going to go left 2, dot that in, and then down 3. And I'm not picky about points for this. You could just, graph that in. Just don't run into the asymptote. That's the only thing that I would have to take off for is cross this. Don't cross. All right, domain, as you sweep left to right, who is not invited to the domain party? We want everybody except who? -2 is a troublemaker, kick him out, right? It's going to be negative infinity to -2, union -2 to infinity. What we're saying is we want everything to the left of -2, everything to the right of -2, but not -2. And the range is going to look much the same way, it's just downwards to upwards. Who is not being invited to the range party? -3. So you're going to write it the exact same way, except leave out -3. Because the graph is never going to touch there. All right, these are the hardest things, so I'm going to do that last. It's going to involve work, little work, not a lot of work, just little, but you will have to do some work, okay? Increasing, decreasing. As we read left to right, what is this graph doing? Yeah, it decreases all the time, right? So increasing is none. And if it decreases all the time, that means for the entire domain. It decreases for the entire domain. So you can just copy that answer over, which is kind of nice. All right, vertical asymptote. It's at -2, but is it going to be x equals or y equals? Good, x equals. So x equals -2, horizontal, y equals -3. Remember Hoivux, because you got to remember which one is which. And then same thing with the limit notation. This means look to the left side. This means look to the right side. Now, what I get all the time is people are like, Ms. Cole, there are arrows everywhere on this graph. I don't know which ones to look at. My trick is cover up the middle of the graph, and then these are your ends. Where are both of those ends leveling off? They're both leveling off at what number? -3. It's not ever going to actually touch -3. It's just behavior. It's just where's it headed. So if there is a horizontal asymptote, these will all match. Whatever that horizontal asymptote is, that's what both the end behaviors are going to be. All right, now let's do the intercepts. X-intercept is going to have to be something 0. I'm going to do this down here. You're going to have to set this equation equal to 0 and solve it. Pep talk. If you're lazy, you won't get through it. This is not about intelligence. This is about having a good work ethic. It's going to be like maybe 4 or 5 steps of work, and you're going to have to like write it down. Okay. So what would you do to start solving this? Add 3. Perfect. See, it's not hard. You just have to write it. All right, then what? I'm going to give this a hug. Yeah, multiply that to the other side. So I'm going to multiply that x plus 2 to the other side. Save myself some space. I just kind of wrote it over there. All right, then what do you need to do with that 3? Yep, distribute. Perfect. All right, so we're going to have 1 equals 3x plus 6. Now it's kind of like an algebra 1 problem. We'll subtract the 6. 1 minus 6 would give you negative 5. And then divide by 3. That wasn't so bad, but you have to actually write it down. That's my pep talk. I believe in all of you, and I know that you can do that, but you have to write out the steps. So negative 5/3, comma 0. Sorry, slide that down. All right, the y-intercept is going to be 0 something. That's a little bit easier. All you have to do is plug in 0. So if you plug in 0 for x right there, 0 plus 2 would just be 2. You get 1/2 minus 3. And so you need to get a common denominator. So here is the $1 million question. How many halves is a whole 3? Good. 6 is 2 times 3. So 1/2 minus 6 halves is negative 5 halves. So you have 0, negative 5 halves. You usually get asked at that point. But Ms. Cole, I can just do in my head, 1/2 minus 3 would be negative 2.5. That's cool. But what if instead of halves, it was sevenths? You still need to be able to get a common denominator, because if it's not halves or fourths, it's going to be a little bit tough. All right, so this one is square root. How has it been shifted? Like using words like up, down, left, right, how did it move? All right, down 5 and right 1. So we're going to go down 5, right 1. That's our starting point. It's going to do something like this. It's going to go to the left, and that's because of the reflection. So I would just try to get a few more points. If you plug in something that doesn't work, just pick something else. But since we're here at 1, I'm going to try 0. Let me talk you through it. Are you all ready? 0 minus 1. Good. But we're going to negative the negative 1. So it's 1. Good. Square root of 1 is 1. And then 1 minus 5 is perfect. Negative 4. So we get that. Now, for the sake of time, I'm going to tell you the next number that's going to work out nicely would be negative 3. But like if you tried negative 2 and it didn't work, you would just pick something else, you know? Negative 3 minus 1. Negative 4. We're going to negate the negative 4, so it's 4. Square root of 4, 2, and then 2 minus 5 is negative 3. And there we go. So domain, you're scanning left to right. So we want negative infinity up until what x number? Good, 1. And 1 will get a what? Bracket. There is actually a point there. All right, range, we're scanning downwards to upwards. So we're starting at negative 5, and then it's going to go up forever. I know it doesn't look like this arrow is pointing up, it's being kind of lazy, but it will keep going upwards forever. So we want bracket negative 5 to infinity. Now intercept, the y-intercept, we can just look at it and go, oh, it's right there, 0, negative 4. But hey guys, look, it's not on our grid, it's gonna go off the grid, but isn't this eventually gonna hit the x-axis, like somewhere very much negative over here? So you're going to have to set the equation equal to 0. It's going to be a little work, not a lot of work, but just a little bit, okay? You're going to take this equation, set it equal to 0. I'm just going to write it off to the side here. And then we're going to solve that. So hey, everybody, what would you do to start solving that? Add 5. I'm writing down every last little step because I'm doing the problem in front of all of you and explaining it. If you do some of it in your head, that's cool too. What would you do next? Square it. 5 squared is 25. And then everybody watch this. Just watch. Stop what you're doing and look. This is the easiest way to deal with the negative. Are you all watching? Just watch. I'm going to erase it from here and put it over here. I erased it from the left side and I put it on the right side. The easiest way to deal with that. All right, and then the last step would be add 1. So we get negative 24. Now, does that make sense that it would be like way far over here? Yeah, because this is not in a big old hurry. So negative 24, 0. Just make sure it makes sense. Okay. Increasing, decreasing, we're going to read left to right. So I know this is confusing because the arrow is right there, but you still have to read left to right. So as we trace left to right, what is the graph doing? It is decreasing all the time, which means for the entire domain. So you can copy that domain over. I don't care about the bracket versus parenthesis on this. If you put a parenthesis on that, I don't care. I am not going to have that argument for increasing, decreasing. The only thing I would have to take off for is if you bracket an infinity. You can't bracket an infinity. And then there's only one line for end behavior because there's only one end. We can only look to the left. You can't look to the right because there's nothing over here. So limit as x goes to negative infinity of the function. Where is this arrow headed? I know it's not in a big old hurry, but what direction is it going? Yeah, positive infinity. It's headed upwards. Again, I know it's not like very dramatic, but going up. All right, relative maximums and minimums. Here's our relative maximum. It is the 0.64. And just remember, you have to write it the other way around. So it would be 4 at x equals 6. Oh, I'm sorry. 4. Thank you. Where did I get 6 from? Yeah. Thanks for giving me that one. 4. Okay, so actually, in that case, because they were both 4, you almost kind of couldn't get it backwards, but cool. All right, let me make sure I read this one correctly. -2, -9. So it would be -9 at x equals -2. I'm going to take it that those went okay. Okay. All right, here, this graph is increasing all of the time. It increases through this section. That's not constant there. A cubic graph is going to keep increasing all the time. So that'll be negative infinity to positive infinity. The other two are none. And then this one, what are we doing first? Reading left to right. What are we doing first? All right, decreasing. And if you want to put in your negative infinity, positive infinity, you can do that. Decreasing is negative infinity until 1. And then we're constant from 1 until 5. And then we increase from 5 to infinity. This was a mistake and I apologize. One of these circles, and it doesn't actually matter which one, but one of them needs to be an open circle. You can't have 2 closed circles like that. That would fail the vertical line test. So I apologize. Just make that one open. I'm really sorry. All right, so for number 7, find the value of a that makes the function continuous. If you want it to be continuous, that means the 2 pieces have to link together. So what do you want to do with these? Yeah, perfect, set them equal. If you set them equal, I'm going to give you a point. All right, and then you want to plug in the x number where you want them to meet, which is -2. So we're going to plug in -2 for x and then solve it. So -2 plus 5 would give you 3. -2 squared is 4. So I'm just going to write that as 4a. And then we're down to kind of an algebra 1 problem. We'll add over the 1, divide by 4, you get a equals 1. Are we okay there? Okay. Set them equal, plug in whatever value it is that you're trying to make it continuous at. All right, state the x values where this graph is discontinuous. All right, boys and girls, there's 3 of them. Can anyone give me 1? All right, -5, is that removable or non-removable? Removable, we just removed a point. All right, what's another one? X equals what? All right, 0. Now there's a jump there, so that is non-removable. And then the last one, if you want to dot this in, I know it's invisible, but we have an asymptote there at 4. So X equals 4, and an asymptote, would that be removable or non-removable? Non-removable. All right, domain and range. I know this is really disjointed, but as you sweep left to right, like we're scanning left to right, we don't lose -5 because we actually have that floating point there. And you don't lose 0 because this piece picks up where that one leaves off. The only number not invited to the domain party is 4, where that asymptote is. So we're going to leave out 4. And then range, scanning downwards to upwards, the only Y value that gets left out is where this hole is here at -2. So -2 gets left out. Everything else, as you scan upwards, you get all those numbers forever. So the only one we're leaving out is -2. So just do like scanning, left to right, and then downwards to upwards. Or evaluate. All you have to do is make a decision. And I know that that can be tough, all right? Is your number smaller than 2 or greater than or equal to 2? All right, where are we going to plug in 0, first or second? All right, first, if you plug in 0, you're going to get 3. All right, where are we going to plug in 1? First, if you plug in 1, you get 5. Perfect. And then 2 would be the second piece. That's where the equal to is. 2 minus 3 would be -1. Squared is 1. And then 1 minus 1 gives you 0. All right. I know easy and difficult is an opinion thing. My opinion is this is the hardest question on the entire study guide, on the entire test, because I know graphing is tough. All right. Just do your best. This line went up 3. So you're going to start at 0, 3. So point right there. And it has a slope of 2. So you're going to go up 2 over 1, but only until you get to 2 on the x-axis, because that's where this domain got broken. Remember when we made the flip book and we actually like took scissors and physically cut it? Remember that? It's exactly like that. It's getting cut at 2. And what kind of circle do you want at 2? Good, open. So just make sure that's an open circle. And then you can put as many points as you want go in this direction because it's going to go that way forever. So it looks like a clock hand. All right, and then the other piece is a parabola. How did this get shifted? Right 3, down 1. Good. So we're going to go right 3, down 1. That's like the center of it. And then I'm going to plug in 2. We would want a closed circle there. And actually, we already plugged in 2. We got 0. So 2, 0. And then because it's going to be a parabola, you're also going to have a point at 4, 0. Like it's going to be symmetric around that center point. You can always make an XY table and plug in as many more numbers as you want, but work smarter, not harder. If you know it's going to be symmetric, you can get that buy one, get one deal with points. You guys are really eager to turn over the page because I know you want to be done, but does that go okay? The tests are a lot easier for me to grade if all the answers are right. That's why I put a lot of effort into making sure you're all ready, because then less work for me and everybody's happy. Right? So using this graph, we're going to evaluate. So you need to find -2 on the graph. It would be -2 comma what? I think those are the easiest ones. Like you just find it on there. All right, f of -1, 4, and then f of 3 is 4. That's constant at 4. So like every value would be 4 there. And then your equation. This went well on the quiz. Just do it again. We're going to write an equation for this parabola. So how did it get shifted? All right, left 3, down 2. Left and right is kind of backwards. So it'll be x plus 3 squared because it's a parabola. And then perfect. Thank you. -2. And then the domain for that, it got cut at -1, or I should have asked you that. Where'd the domain get split, guys? -1. And we wanted x to be less than, good, -1. So actually, if you want to even go ahead and put that this one's greater than or equal to -1, you can do that right away. That's where it got split. And that function's real easy because it's just going to be what? Like literally just 4. It's constant function at 4. Trying to give you a break on that. All right, and then these last ones are your intermediate value theorem. It's going to involve writing a sentence. You're going to be totally okay. It's going to be all right. Okay. Does this function have a value c on this interval such that your output value is -2? Remember what intermediate means. If you have beginner and you have advanced, intermediate means what? In the middle. You're going to plug in these two values, and the goal is to show that -2 is in between them. So let's see what we get if we plug these in. We're just going to see what the output values are. If you plug in -2 here, -2 squared, 4, and then -5 times -2, negatives cancel, that would be +10. So 4 plus 10, perfect. We get 14 for that one. That's the output. And then plugging in 3. 3 squared is 9, and then it would be -15. So -6. Here's the question. Is -2 in between these? Yeah, do you remember doing this on the delta math? And you had to check, is it in between? That's what we're doing. Okay, so here's your sentence. Since f of x is continuous, you have to mention that. And this is continuous because it's a parabola. A parabola is continuous, the x squared then. Since f of x is continuous, and now you can be as wordy as you like here, but you have to state in some capacity that -2 is in between these. This is the shortest way to do it. F of 3 is less than -2, which is less than f of -2. That's the most succinct way to put it. But if you don't like that, you can write it in words. And I get people that like to do that. -2 is in between f of 3 and f of -2. So since all that is true, here's your big conclusion. You get to recopy the problem. Do you remember that in English class for your conclusion, you basically restate the prompt? Can you guys pull your masks up over here? All right, so since all that is true, there is a value C on the interval -2 to 3. They should be parentheses. If you put brackets, I'm not gonna mark it wrong. On -2 to 3, such that, don't you love that? Such that makes you sound really like higher level. Do you know what I'm saying? Like such that. You throw that into an argument that you have with somebody. Blah, 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 such that f of c equals -2. Here's what I'm going to be looking for when I grade this, okay? Did you find these values? So if you lose your mind, but you're like, I can plug those in, you'll get a point. Did you say it was continuous? If you forget everything, dear Miss Cole, I've lost my mind, but the function's continuous, then I can give you something, right? Did you state the in-between part, and then did you repeat the question? All right, so use the test to help you because it's going to be written on the board. All right, and then the last one. Consider the values given for the continuous function. You have a big hint right there. On what interval or intervals must there be a 0 justify your answer? There's only one interval where there has to be a 0. It'll be from where to where? Good, nice job. All right, here's your sentence. F of x has a 0 on the interval 4 to 5 because, and then what do you have to say? 0's between those and the function is continuous. Good, because f of x is continuous and 0 is between these. So the shortest way to say it would be like this. The other thing I'll accept on this one is if you don't want to write this, I'll accept changes sign. If you say f of x changes sign, that's okay too. I'll accept that. But again, what I'm looking for is the answer. So like this interval stating continuous, and then in some capacity saying that 0 is in between. You could also say changes sign. I'll accept either one of those, but those are the things that I'm looking for.